Alright, today we're going to talk about something called the product rule. This is when we have more complicated problems where we're multiplying. We can use the product rule to make life a little bit easier. Excuse me. So today's terms and notation. Product rule. If you've got two functions, function u and the function v, and you're combining them together so that you've got y equals u times v, then the derivative of y in terms of x is equal to the derivative of u times whatever v was plus whatever u was times the derivative of v. Or I think a much easier way to write that is this right here. The derivative of y is equal to the derivative of u times v plus u times the derivative of v. Technically, it doesn't matter which one you do, you're just doing a mix and match. You're doing the derivative of one times the original and then switching them around and adding them together. However, I would recommend you always start with the derivative of u. That'll help when we get to our next rule, which will be the quotient rule. The reason I wrote this one down with all that dy, dx stuff in there is that's how it appears in your formula packet. But again, dy just means derivative of y in terms of x. So anytime you see du, just think u prime. All right. For example 1, we've got the function y equals x squared minus 4 times the square root of x. We want to find the derivative of y in terms of x. It'll help here if you label your u and your v, the two parts that are being multiplied. Find the derivative of each of those individually and then start putting it into your formula. Maybe take about 5 or 6 minutes on this one. You can pause the video now. All right, let's go over this one. So we've got two parts. We've got a u part, which is x squared minus 4. We've got a v part, which is square root of x, also known as x to the 1/2. We always wondered why those exponent rules were going to be so useful. When we get to calculus here, we're using them all the time. I'd like to take the derivative of each one of those. So u prime is going to be 2x. And v prime is going to be 1/2 x minus 1, to the negative 1/2. Now the product rule says that when we have a function y equals u times v, the derivative of y is equal to the derivative of u times whatever v was plus u times whatever the derivative of v is. So I know u prime, I know v prime. All I have to do is plug them in here. So the derivative of y, or dy dx might be better since that's the notation they used. We'll write down the derivative of u. So that's 2x times whatever v was, and that was square root of x, plus u, which is x squared minus 4, times v prime, which is this. I should probably clean this up here. So we've got a negative exponent, so the x goes into the denominator with the 2. So I have 1 over 2, and then the 1/2 is a square root, so 1 over 2 square roots of x. So I'm going to write it just like that. I don't think there's too many like terms we can deal with here. If you want, you can bring this 2 times square root of x and put it in the denominator here. So you'd have a final answer of 2x square roots of x plus x squared minus 4 all over 2 square roots of x. And that's the product rule. All right, for example 2, we're going to do the product rule again. Technically, there's actually a little bit of chain rule going on here as well. Let's take about 5 or 6 minutes to do this one. You can pause the video now. All right, let's take a look at this one. We've got a u part and we've got a v part. U is equal to 2x, and the derivative of u is just going to be 2. Our v part is equal to x plus 3 quantity squared. It's technically the chain rule that we're doing here. You've got some stuff to the second power, so we do 2 times that stuff to just the first power times the derivative of that stuff, but the derivative of that stuff is only 1, so it ends up just being 2 times x plus 3, also known as 2x plus 6. Alright, now we know that the chain rule says the derivative of y is going to be equal to u prime times v plus u times v prime. Again, this is in your formula packet, it just looks a little bit different, but it's not a hard one to memorize. So let's just start plugging in. We've got u prime, which is 2, times v, which is x plus 3 quantity squared, plus u, which is 2x, times v prime, which is 2x plus 6. I actually might go back to the previous one that we had where I didn't distribute it. That way it's all nice and factored. So I'm going to rewrite this as 2 times x plus 3. Nothing we can really clean up here, so we have y prime is equal to 2 times x plus 3 to the second power. But these I can multiply. 2x times 2 becomes 4x times x plus 3. Again, we could distribute here 4x times x would give us 4x squared, and 4x times the 3 gives us 12x. But everything else is so nice and neat and factored, I don't know why we'd want to have one part that's all factored beautifully and another part that's all expanded. So I think this is probably the best way to write it. Alright, and we'll have an exit ticket and homework on page 369, numbers 1, 2, and 3.